Okay, so now I'm going to be talking about how a student will be able to use a cone to find the true length of lines. So far we've talked about rebatments, we've talked about auxiliaries, so now we're going to talk about using a cone to find true lengths of lines. So an example of when this would be used could be if we had two different diameter ductings, round ductings, and we wanted to join them. If they were in line with, if they're in line with each other, we'd be using a right cone like the cone I have here. But if they were off center, we'd be using an oblique cone. And from our studying of oblique transition pieces, we know that a cone can be really beneficial to help us find true lengths. It just makes it an awful lot easier rather than having to do different auxiliaries and different views. Just makes it a lot simpler. So this is a representation of a cone. It's not a perfect cone, doesn't really have to be. It's just something to help teach the principles to the student. So all I've done here, just really quickly, drawn some lines down along the surface. Then pink lines are actually generators, and we know from our studying of solids, of right solids, that a cone is made up of an infinite number of generators. Now, what we can do then is we can explain to the student how our point A is going to be the top of our cone, and our point B is going to be a point along the base somewhere on our cone, and the line from A to B is running along the surface of the cone, so it's one of our generators. The students are still going to find that hard to understand, so something that I think can be really easy for them to use, and they're all going to have them either in their math sets, or they can use their big ones for DCG, is a set square and a protractor. So basically I set my protractor down here on my page that I have folded up to represent my vertical plane, horizontal plane, and my XY line. And I can set it up and line it up in plan with the line AB, and explain then, and the students will be able to see it, that the long edge of my set square is actually the line, because that's a generator running along the cone, and I can rotate it from A back to my XY line and mark that off on my XY, and that'll give me my true length of my cone, because when we rotate it back, it's parallel to the vertical plane, which means we're standing and it's perpendicular to us. So when we're seeing it from a 90-degree angle, we can get its true length. So we can draw in our true length line here. So some students might still struggle to be able to see that, even though they will have these and will be able to use them. Something that's nice and easy then is I'll be able to fold out this sheet and explain to the students that this is what it's going to look like for you. So just draw my XY really quickly, my XY, and I'll be able to flatten this sheet back out and explain to the students that that's what it's going to look like for them. They're going to be able to see the plan view of the line, which we set our protractor onto, and our set square was rotating along, and they're going to be able to see an elevation. And it's only when the sheet is folded up that they might be able to connect them. But we're using this cone and our protractors and our set squares, and just a really simple drawing like this, it could help to develop that understanding in the kids. Now using a piece of paper like this is very good, but I've also given a sketch showing our cone. A little sketch like that, do it with the students at the start, get them to sketch it out themselves in the top corner of a page, even if you haven't taught them about it yet. And then when it comes to the part of the question whether they need it, they'll be able to reference back to that sketch, and some of the brighter students might think, okay, why did he get me to do that? And start to realise, okay, this is what's going on, we can rotate this round. Whereas the weaker students then will be able to really focus on their models, and even when the demonstration is finished, even if their set squares and their protractor doesn't work, for them to help them visualise it, that sketch might just be enough to help them have that light bulb moment. So none of the resources I've used here take me any more than 2 minutes to get ready. So if you're in the middle of a lesson and all of a sudden you're realising things aren't going right, it's very easy just to turn on the visualizer, make a model with the students, and that could just give them that concrete experience, and even allowing them to make a model, let them make a cone, or give them an A2 page or an A3 page and let them make an XY and a cone to find its true length. It could just be something very quick, but could give them that concrete experience that allows them to really understand the principles behind it. We can also use this and do this on SolidWorks. We can draw a line in SolidWorks along the surface of our cone and rotate it around, and we'll be able to see the same thing. Just might take a little bit longer, especially because the students might not be very good at SolidWorks. We should be good at it, but the students might take a little bit longer, and as well we might not have the facilities in the school to be able to just go into the computer lab whenever we like. So these are just 3 little simple tools, my set squares, a simple cone and a sketch in the corner of the page, and they all give very interactive, very concrete concrete examples for the students to understand the principles behind using a cone to find the true lengths of an oblique.